Hello student, I am Dr. Samir Dey and you are watching my YouTube channel where I uploaded videos for engineering mathematics. These videos are helpful for B.Sc as well as B.Tech and M.Sc students also. If you are preparing for any competitive exam where higher mathematics is asked, my YouTube channel is very helpful for you. Okay, today I'll discuss another topic that is called Bernoulli's equation, and you can say reducible to linear differential equation. So already you know what is your linear equation. Linear equation, there are two types of linear equation you have. One is y on x, another is x on y. I can revise once again. Suppose you have dy dx plus pxy is equals to qx. So if you can see any single y is there, that is called linear equation of y. If you can in reverse, if you can see in reverse, dy plus p and y into x is equals to q on y. If you can see any single x is there, then you can consider this is a linear equation of y with respect to x. Okay, so Bernoulli's equation means some extra function of y will be here. For in this case, some function of extra x will be here. Okay, so for example, if you can see some linear equation, that is your dy dx plus pxy is equals to, suppose qx is a linear equation. If you can see some function of y is extra, then this is called Bernoulli's equation. Okay, same thing is here also. If you can see dx dy is here plus p1y into x is equals to q1y is here. But if you have some another function of x is here, then it is called a Bernoulli's equation of x with respect to y. Now in this lecture video, I will discuss how to solve a Bernoulli's equation. How to solve a Bernoulli's equation means this one as well as that. So this is for Bernoulli equation for y with respect to x, and this one Bernoulli equation of x with respect to y. Okay, now I am considering one simple example. Now is also very important. Solve dy dx minus tan y 1 plus x is equals to 1 plus x e to the power x into sec y. Okay, now try to understand how to solve this. It's very easy. Now you can see from the differential equation, dy dx is here on the right. Next you have some y term, single y term you have along with some x. Just you can see on the right side you have some extra y term, so that's why it is called Bernoulli equation. Okay, so now try to understand how to solve it. Please write down the given differential equation is. What is your differential equation? Please write down dy dx minus tan y of 1 plus x is equals to, please write down 1 plus x e to the power x into sec y. This is number 1. So this is your extra term you have on the right side. Then what you do? First you have to divide it. If you divide, it is coming 1 by sec y dy by dx minus tan y sec y 1 plus x is equals to 1 plus x into e to the power x. Now you can see on the right side part is free from y. Okay, now you can see, then if it is confirmed that there is no y term, then you move to the this term. First you have to simplify it. So here you may write it is your cos y dy by dx. Tan y means what? Tan y is equals to sin y by cos y. What about your sec y? Sec y is equals to 1 by cos y. If you can simplify, it is coming, please check, it will be sin y by 1 plus x is equals to 1 plus x e to the power x. After simplification you have this. Is it clear? Basically tan y by sec y, it is coming sin by cos into cos by 1. So cos cancel, so sin y is left, so it will be sin y by 1 plus x. Now you can see, so in this Bernoulli's form there is a unique features you have. I'll show you. So if it is free from y, okay, then you switch to the next term. Just you come to this. Now whatever the y term you have, I'm talking about whatever, means full y term you should consider as a z. Okay. So shall I move to the next slide? Okay. So please write down, let sin y is equals to z. Is it clear how to decide that? I'm not talking about sine, only y function I'm talking about. So after division of the extra term of y, whatever the y term you have the second, so that term you should consider as a z. Okay, now you differentiate with respect to x. It is coming cos y dy by dx is equals to dz by dx. So another interesting feature is there. You can see when you will consider that function sin y as a z, if you differentiate, automatically that term will come up automatically. If you differentiate, maybe along with sin plus minus whatever, but that same expression will be here, but just you check, already you have it. Sin y derivative cos y dy dx equals to dz by dx. Just you can check, same expression is coming up. So this is the beauty of this Bernoulli's method. Clear? Now you substitute this in this relation. Okay. So if you can consider, this is number 2. Okay. This is number 2. So please write down, from 2 dy please write down dz dx minus z by 1 plus x is equals to 1 plus x e to the power x. What is this? Please write down, which is a linear differential equation. A differential equation, which is a differential equation of what? Now please check which variable is allowed with only single times, only one. Yes, only z single time. So please write down of z with respect to x. Clear? Now you compare dz by dx plus pxz, that is your qx, number 4. I have considered dz by dx according to the format wise. Okay, dz by dx plus pxz is equals to qx. Now write down, comparing 3 and 4 we get. Now please tell me, what is your px? Anyone? What is your px? Just you compare, your px is minus 1 by 1 plus x. Very good. What is your qx? Qx is equals to 1 plus x into e to the power x. Clear? First step to decide what type of problem you have. Second step, what is your extra y term you have, divide this. After simplification you check what about the middle term you have, middle part. So that part, that y part, you should consider as a z. If you differentiate, automatically this first part will come up, first part. If it is not coming, so that means you should consider in your calculation there may be some wrong, incorrect part you have. Okay, so you should revise it. So now after getting the derivative, you substitute in equation number 2 we get. So this is your equation number 3. What is this? Basically, it is a linear differential equation of z with respect to x. Now already you know, if you have a linear equation, already you know how to solve it. Okay. Now you compare with the standard form. This is your px and this is your qx. What next? Anyone? What next? After knowing it is a linear, then you have to find your integrating factor. Very good. So now you calculate integrating factor is equals to e to the power px into dx. So it is coming e to the power minus 1 by 1 plus x into dx. It is coming minus log of 1 plus x. Ultimately, it is coming e to the power log of 1 plus x to the power minus 1, like 1 plus x to the power minus 1. Okay. So this is your integrating factor. Now already you know the formula, the solution. The solution is z into integrating factor is equals to qx into integrating factor into dx plus c. So here z, what is integrating factor? 1 by 1 plus x. What is your q? 1 plus x into e to the power x into 1 by 1 plus x into dx plus c. Now what is coming up? Z by 1 plus x is equals to, if I simplify, it is coming integration of e to the power x dx plus c. Okay, so now you integrate this. Simple integration is there. Z by 1 plus x is equals to e to the power integration is e to the power x plus c. Okay, your calculation is over. But you can see our problem is given in terms of y, but you have substituted some other variable because of the transformation, or because of getting your linear equation. Okay, now your solution is available with you in terms of z and x. Now you have to replace your z in terms of y. What is your z you have considered? Yes. What is your z? That is sine y. Please write down sine y by 1 plus x is equals to e to the power x plus c. So please write down, this is the solution of the given Bernoulli's equation. Please check. Please check. Okay. If any doubt regarding linear equation is concerned, already I have uploaded one video based on linear equation. Please try to go through. Okay, thank you, and please do subscribe my channel, and please share this video link to all of your friends. Thank you.